So this could be our second to last notes in Algebra 1, and this is going to be applying systems of linear equations, and this is lesson 6.5. And so far we've been looking at what a system of equations is. It's really just two separate equations, and we look for answers that fit them both. And sometimes it's just one answer. Sometimes if they're parallel equations, there's no answer. And sometimes it's an infinite number of answers if the lines overlap. Okay, so for this one, we're going to look at a couple examples of the best method used to solve. Okay, so if you remember, some of the examples that we could use to solve these, the first one is graphing, but really graphing is only an estimate, and it might not give us an exact answer. Sometimes if we graph the two equations and they lie right on a point like 1, 2, it's going to give us an exact answer, but a lot of times it's not. So graphing, probably not the best. And then we have substitution. Substitution is where we have, x and y variables, and either x or y are equal to something. We can then plug that variable in, solve for the single variable that's left, and then plug that variable back into the equation and get the second variable. So sometimes you can use that if you have y equals something or x equals something, where it's easy to manipulate in the equation. Next we have addition and subtraction. If you have two equations and they have opposite coefficients like 6x and negative 6x, if we just add them, it will eliminate one of the equations. And really that's what addition, subtraction, and multiplication is really talking about. We're trying to eliminate one of the variables. And really substitution as well. Okay, but you're looking at addition, it's opposite coefficients. So if you have 6x and negative 6x, then we can just add them together. One will be eliminated. We can solve again for that other variable, and then plug that answer in to solve for the one we canceled. Then we have subtraction if they're the same coefficients. So if you have something like 3x in one equation, 3x in the other, if we just minus one equation from the other, we will eliminate that variable. Again, we can solve for the remaining variable, plug that answer in, and solve for the one we removed. And finally, multiplication. If we see that we can't just add or subtract, if we don't have an opposite or if we don't have the same variable, then we can multiply one of the equations by a certain number to make them the same. And sometimes you might have to do both. So it's very possible that you could have to do both equations. So multiplication is probably your last thing you think of. And that's kind of the 5 things. So you have graphing, substitution, elimination through addition, subtraction, and multiplication. So let's look at some examples and see what we could do. So here's example number 1. Okay, so here we have 4x minus 4y equals 8, and 8x plus y equals 19. So this one, you might see this y by itself. So we could just add 8x to both sides, just a pen to work here, and then this will eliminate, and we'll have y equals 8x plus 19. Then we can then plug that in for y to the other one. So if we have 4x minus 4 times 8x plus 19 equals 8. Then again we can do the math. It's going to be 4x minus negative 4 times 8 is 32x, and then negative 4 times 19 is going to give us 36, carry the 3, 76. It's going to be a negative, and then that's going to be equal to 8. So then we're going to cancel some things out. We have 4x and minus 32x, so that's going to be negative 28x, and then we're going to add 76 to both sides, and that's going to give us 8. That's going to give us 76. Going to give us 84. Okay, and then it looks like if we divide both sides by negative 28, we should get x. Looks like negative 3. Let me pause here. I'll do the math on my calculator and get right back to you. Okay, so you see I got my calculator here. Let's just do 28 times 3. That gives us 84. So it's going to be a negative 3. That's our x. And then we just plug that back into the equation. when we started with up here. So then we're going to go 4 times a negative 3 minus 4y equals 8. And then we're going to have negative 12 minus 4y equals 8. And then we're going to add 12 to both sides. And we're going to get negative 4y equals 20. Divide by negative 4. And you're going to have y equals negative 5. So our answers are negative 3, negative 5. And then we can just plug in one of these to the other equation to make sure we got the right answer. And we'll just go with, we'll solve this one for x and then see if we get negative 5 for y. So we got negative 8 times negative 3 plus y equals 19. So then we're going to have negative 8 times negative 3, that's going to be 24, plus y equals 19. And then we're going to get minus 24 to both sides, and we're going to get y equals negative 5. And that's our answer. Okay, so we saw that's one example. So here we use substitution. Let's look at another example. Just ignore all this over here. Kind of ran over a little bit. So here we have 5x plus 7y equals 2, and negative 2x plus 7y equals 9. So here we look for variables that are the same, right? So if they're the same, we are going to subtract. Okay, so then we're going to have 5x minus 2x. So that's going to be, think about, we'll just do it over here. 5 minus 2 minus a negative 2. So we change the sign and add. That's going to be 7x. These cancel, equals 11. Okay, oh, I'm sorry, we're 2 minus 9. That's going to be minus 7. We're going to divide by 7, and x is going to be negative 1. Okay, so we got our first answer. X is negative 1. So then let's plug it back into the first one. And we'll actually go to this one. So negative 2 times negative 1 plus 7y equals 9. So negative 2 times 1 is 2 plus 7y equals 9. So we're going to minus 2. We're going to get 7y equals 7. Y equals 1. So we've got negative 1 and 1. That's our y. Okay, that's y. So let me just plug in the other one up here to make sure it works. So we'll just do x again. 5 times negative 1, that's x, plus 7y equals 2. 5 times negative 1 is negative 5, plus 7y equals 2. Then we're going to add 5 to both sides. 7y equals 7, y equals 1. So we plugged in a negative 1 for x, we got a 1 for y, that's good. So there's two examples. So maybe let's look at one more here. Let me pause this for a minute. Okay, so the last thing I want to show you is where you take a graph, convert it into an equation, and then see if you can determine something from it or an answer or whatever it is. So we're going to look at this really quick. I'm going to probably show you one in class. I'm just going to kind of explain it here. But whenever you have a graph and you have to interpret it, so it's going to give you two lines in a coordinate system. I'm going to show you in the book. One we're going to go over in class. I just want to show it to you, and then you can check it out in class. Okay, so we got this thing here. We got these two equations. So let me kind of explain. So you're going to see these two equations, and you're going to convert them first into equations. Okay, and the two things to think about are slope and y-intercept. So here we can see this top one, the blue one, looks like y-intercept is 20. So that would give us 20 for the y-intercept of 1 if we were writing in slope-intercept form. And then we would see the other one is 0. Okay, so if we were going to write that, let me write that and show you. So we're going to have slope for the 1. So for the blue line, sorry, y-intercept, the blue line, I'll show you this over here. So for the blue, it's going to be, looks like 20. Plus 20 is your y-intercept. And for the red, it's 0. You can kind of see that right there, right? So then we just kind of look at the slope here. Let me see if I can get a little closer so you can kind of see it. So we're going to pick a point here, perhaps. Let's see. let's go from here, and let's see, we're crossing another point. So we got 1, 2, 2 over 1. So the slope is, for the red, is 2x. So y equals 2x. That would actually be the equation for that one. Okay, and then if you're then going to do the other one, the blue line, we would then say, let's start at this point right here, and we go 1 and 1. It's a slope of 1. Okay, so for that with the 20, it would be y equals x plus 20. So then we would have the two equations here. Okay, so we'd have y equals x plus 20. That's our slope, and then this is the y-intercept. And for the other line, it'd be y. The slope is 2x plus 0, so we don't have to write it. So then we have these two equations. In class, I'm going to show you the rest of this. Make sure you get this into your notebook, and I'll see you in class.